Hello, my name is Uwe Artmann. I'm CTO of Image Engineering. IEEE-P2020 is the standard for image quality in automotive systems. It's the first international standard in this topic. So how can it help you? Let's have a look at that. Spatial frequency response is another metric in there. Also there, it is nothing really complete new. So like with noise, but it's good to define that in the automotive environment. So the method that is also used here for the SFR or spatial frequency response is what is called SFR in ISO 12233. So that's the slanted edge approach, as it's commonly called. So when the workgroup started, there was the ISO standard 12233. 2017 was just published and there was no indication that there's going to be an update anytime soon. So P2020 started to define modifications to the standard that are actually needed. While it took a while to develop P2020 and the ISO committee continued to work on ISO 12233, it is a case now that that ISO 12233 was published before the IEEE P2020. So that's why the P2020 references the ISO standard and does not describe certain modifications to that anymore, even though it was already identified by the experts in the IEEE committee that these findings and that these modifications are useful, especially for the automotive application. Therefore, it did not describe the same thing in the standard than what the ISO does, so it just references that. What is done in the P2020 document is to define certain metrics that are derived from the SFR. So the SFR, you see that in the lower left image, the red line, that's what you might measure from a camera. That is what you get from a single edge, and that is what you measure, and from that you can derive different metrics. For example, SFR 10 or SFR 50, so that is the spatial frequency for a given response. But also like SFR at half Nyquist or at quarter Nyquist, that is the response for a given spatial frequency, so in the opposite direction. For human vision applications, which you also have in automotive, for like rear view cameras or in-cabin application, you then have the acutance. Which is the weighted SFR with the contrast sensitivity function for human perception. And then there are some definitions how you get the corner variation, SFR 50 and acutance, so that with that you can identify misalignment of sensor to lens to sensor, and the SFR max as an indicator for sharpening. So if you have a processed image, this SFR max is an interesting metric to have a look at. How much sharpening do I have in the image? And it needs to be reported as a set. So because with much sharpening or a lot of sharpening, you can easily increase your SFR 50 value. So if you just know the SFR 50, you don't know if you still have a good image because it might be just a result from sharpening. So the combination of SFR 50 and SFR max, with that you get really the information that you need from your camera.